Okay, now we're going to go ahead and take a look at problem 5 on the week 2 assignment. I'm going to help you to design a spreadsheet if you wish to solve this problem. Fairly simple problem here in that what we want to do is figure out our feed needs for a dairy farm and then figure out, do we have enough corn to make our feed needs. So in this problem, Darling Dairy Farmer tries to determine if she has enough corn grain on inventory. She figures she will need enough corn to feed her cows for 180 days. She feeds 18 pounds of corn per day to an average of 87 cows. Darlene measures her 24-foot diameter grain bin and determines that the corn is 12.5 feet deep. First question, how many bushels are needed to feed the cows until harvest? So okay, let's remember, we build our spreadsheet by starting off with what do we know? We know we're feeding for 180 days. We need pounds of corn per day and number of cows. So let's start there. Let's start number of cows, or whatever you want to start with, that's fine. In this case, she has 87 cows. I'm going to go ahead and wrap text here so that these cells can be more easily displayed, and then I'm going to center. Something that I like to do is keep the data centered. Let's see here. We wanted to feed 18 pounds of corn per day to 87 cows for 180 days. So 18 pounds of corn, number of days. Oops. So I want the computer to tell me how many total pounds. Or I can even say number of bushels. That's probably more user friendly for me because I'm going to measure my grain bin in terms of bushels. So total bushels of corn is going to equal, just like I did on paper here, pounds per day times number of cows times number of days, then divided by 56 pounds per bushel. So number of cows times number of pounds fed per day times number of days gets me total pounds of corn, and then divide that by 56 pounds of corn. 5,033 bushels of corn are needed to finish out feeding this corn, which is what I got by hand. Now the next question is, do we have enough inventory? Now a grain bin is measured, it's like a cylinder. So how do we find the volume of a cylinder? Bushels are actually a measurement of volume. And 1 bushel equals 1.25 cubic feet. So we first must figure out how many cubic feet of corn do we have. Well, we have a 24-foot diameter grain bin that is 12.5 feet deep. Okay, to figure out the volume of a cylinder is pi times r squared times depth. 3.14, in this case, r squared, it's a 24-foot diameter bin. So radius is 1/2 a diameter. Half of 24 is 12. So pi times 12 squared times a depth of 12.5 feet will give us overall cubic feet of the bin. Then we divide that by cubic feet in 1 bushel. So bin diameter, I know that is, 24, and I know that the depth of the grain is 12.5 feet, and I know that pi is 3.14, so I'm just going to go ahead and leave that. And I know that will always be a constant, so I don't need to make a cell for that. So I can make a cell here and then turn it to bushels later if I want. I could have just made this straight into bushels by dividing by 1.25. But let's just do it this way. Again, 1/2 of diameter. So I just made the computer take 0.5 times diameter of the bin, so that will change it into a radius, pi r squared. So r squared, so that's radius. I'm having it multiply it by half of itself again. Shoot. Okay, start over. And I can make this even easier. Let's just call this bin radius. I can do that in my head. That's easy. I don't need the computer to do that for me. So I'm going to take 12 times 12 again. So pi r squared. So I got to add or multiply by pi here, 3.14. Pi times r squared times depth. Sorry about that. I didn't give enough room. So stupid. Can make this a little bigger here. Equals, okay, r squared times pi times grain depth. No, no, no. Click the wrong cell there. Guess we'll get to do it over again. Okay, pi times r squared times depth. Okay, volume of grains 5,652 cubic feet. Turn that into bushels by simply taking volume divided by 1.25 cubic feet in a bushel. I multiplied there. I needed to divide. Always check your answers, by the way. So I had the computer tell me that. I had the computer tell me that. And this. Very simple spreadsheet. If I change my number, I only need 65 cows worth. Okay, now I know total bushels that I need. I initially had 87. Now, if it was me, I would make another. The next question I have is, I would say, do I have a surplus? Or I would say, needed minus inventory. So that I would know. I had the computer just tell me real quickly. I just merged cells there, by the way, with this button. I want the computer to tell me what do I need minus what do I have. I real quickly have the computer tell me, oh, I'm in good shape. I have plenty of bushels here. I have 512 bushels more than what I need. Now, if I measure my bin and I'm only 10 feet deep, I have in this case, I'm sorry, I need 5,033 bushels. I only have 4,521, so I'm short. I'm short 512 bushels. I said that wrong. So I know I'm going to have to buy 512 bushels of corn. At the same time, if I measured my bin at 14 feet deep, okay, now I'm plenty good. I have more inventory than what's needed. I could change this around also if I wanted to. Might make more sense if I do that. Let's call this inventory over needed. Inventory over needed, which would mean that probably makes more sense. Is what do I have minus what do I need? Yeah, so I have 31 bushels in this case, more than what I need. If I go back to my initial problem, I'm 512 bushels short. Yeah, that makes more sense to do it that way. But you can see, you can very easily adjust how you've computed the spreadsheet. Pretty simple. A very similar problem on number 6. Debbie Dairy Farmer, number 6. Here she's trying to figure out her bunker silo. We're going to do it pretty similar. to the last problem. So here I have number of cows again. I'm gonna wrap text here, center. Number of cows in number 6 is I have 150 cows. That's what's given to me. I know that. Days fed, 90 days. And pounds fed per day. Looks like 25 pounds of corn silage per cow for 90 days. 150 cows are fed 25 pounds of corn silage for 90 days. So how many total pounds of silage? I'm going to say I'm going to label this tons needed. Tons needed will equal number of cows times days fed times pounds per day, divide by 2,000 pounds in a ton. I need 168.75 tons. In this case, we're measuring a bunker. And just like the last problem with the grain bin, we're measuring the volume first. I need the length, width, and height. Length, width, and height of the bunker. So this particular bunker is 20 feet wide, 7 feet deep or high, and 72 feet in length. And I know that it's 0.0175 tons of silage per cubic feet. So to get tons of silage, tons of silage in the bunker, I just simply do this: length times width times height times tons per cubic foot. So what I have on hand is 176 tons of corn silage. What I need is 168. I'm gonna merge all those cells. I'm gonna put my answer here just for fun. I'm gonna say, what do I have minus what do I need? So I'm in good shape here. So as you can see, I can really easily manipulate this data. If I change number of cows, I can add, if I decide to buy more cows, okay, I'm going to be short of silage. So that's the neat thing about a spreadsheet. Again, we can manipulate data very, very quickly. So that was number 6. Hopefully you've enjoyed this presentation and understand how to compute or program a spreadsheet to solve some simple math problems for us. Hope you enjoyed it. Good luck to you.